We are now going to begin our lecture on sampling and the different techniques of sampling available to us to create a good sample. Now, why do we need to create a sample? If you remember, we said previously that any statistical study is done on a population, right? And the population can be people, population can be items like cars or books or stores or clothes. It could be anything, all right? But the size of the population can be huge. It can be an enormous size in millions, hundreds of thousands, millions, even billions. If we want to study a certain characteristic across the world, or on people across the world, then it could be in billions also. For example, when we had the COVID and we were running the race to find a proper vaccine, an effective vaccine for COVID, our population size was in billions. It was applicable to people all over the world because it was a pandemic. It affected every country in the world. So you can imagine the vastness that a population can take. Therefore, it is not possible to perform a study on the entire population. It's going to be extremely difficult and time consuming to get the data from millions of people or millions of items, and it's going to be very expensive as well. Therefore, what we do is we pull a small subset, all right? We pull a small subset from the population of a manageable size. So subset of the population, which is known as a sample, called a sample. All right. And then what we do is we perform all our descriptive studies, our analysis on the sample, on that small subset, which is representative of the population. So we do all our descriptive study on the sample, and once we are done with the descriptive process, we draw conclusions, we make inferences on the wider population. So creating an effective sample is extremely important. The sample should be representative of the population, and because your entire study is as good as your sample is. All right, so it is extremely important to get a proper sample which is going to help us with our study, and later on when we perform the inferential part of statistics or to project on the population, right? So in this chapter, we are going to talk about what sampling is. I think I already gave you a preview of that, but we'll talk a little more on that. And then we'll talk about sampling requirements, which are some conditions that should go into creating a sample. And then we'll talk about the types or the techniques of sampling. Now, what is sampling? Sampling is the process of selecting a subset of the population for purposes of data collection. And once we collect our data in the form of a sample, we also perform some descriptive studies on it. We take measurements on it, correct? And only then, after we complete our descriptive study process, we are ready to reflect back on our population, make estimates on the population from our sample data, right? Now it says here a good sample must be representative of the population for which the study is being conducted. And that's very important. That's a very important condition that has to be met when creating a sample. A sample must be representative of the population. Otherwise, it will not give you a valid statistical study. The statistical study is going to be as good as your sample that was created. So let's say we are studying the mean weights of 10-year-old girls in a country. 10-year-old girls. All right. Now, when we create our population is going to be all 10-year-old girls in a particular country, correct? So when we create our sample, we have to make sure that our sample contains only 10-year-old girls. All right, only 10. It cannot be 12-year-olds, it cannot be 8-year-olds, it cannot be any other age except 10. And the sample must consist of girls, right? It cannot have boys in it, or it cannot have adults in it. All right, so we have to make sure that the uh, the sample is truly representative of the population that we are studying. If we are studying the mean weights of 10-year-old girls, then our sample must also consist of girls that are 10-year-olds and from that particular country that is under study, that is being studied. Right? So what does representative mean in this case? That is, it should reflect as closely as possible the relevant characteristics of the population. So our sample must reflect the whatever characteristic. In this case, the characteristic we are studying was the mean weights. So it should reflect the characteristics of the population. All right. The variable that we are studying is mean weights, and the characteristics of the population would be 10-year-old girls. Right. Now we'll go into the different types of sampling out there. Now these are not the only types of sampling. There are some other types of sampling as well, and sometimes we also combine different types of sampling and come up with a new technique. But these are some of the basic sampling methods, techniques that have been used in the past by statisticians. All right. Now, the first one is the simple random sampling, and that is the basis of all other sampling. All statistical study must be based on simple random sampling. Otherwise, the study is not considered to be fair. It's not considered to be unbiased, right? So simple random sampling, whatever technique you may be using, must be the basis. SRS, it's also known as SRS. This SRS method, or the simple random sampling method, works as the basis of any other type of sampling. The second one is the systematic sampling, and as the name suggests here, there is, as you will see, some system in the way we go around picking our items or making selections to create our sample. Then there's one called the cluster sampling, and this has its own use. And in fact, each of these sampling methods are used for different purposes. And we'll go into that. Then there's one called stratified sampling. And then the last one is not really a good sampling method. It's called the convenience sampling. It's not really, not truly random either. So, but we need to know what it is. All right. But the first four are sampling techniques which should be used, all right, if when creating a sample. Now let's try to understand what the simple random sampling process is about. Now simply put, this sampling method is the good old-fashioned picking a name from the hat. All right, so to give you an example, let's say I'm performing a study on my stat class, on my statistics class. And that is my population. That will represent, my statistics class will represent my population. And let's assume my statistics class has 30 students in it. So the size of my population, which is also denoted by the uppercase letter N, is 30. All right, there are 30 students in my class, so my population size is 30, denoted by the letter N. And instead of studying each and every student in my class, I want to just study a small sample from my entire class, and I want to create a sample of size 5. So I want to create my sample, and my sample size is small n. All right, the lowercase n denotes sample size, the uppercase n denotes population size. Keep that in mind. We are going to refer back to it over and over again. So n is my sample size. That means I want to pick 5 students from my statistics class and do a study, take some measurements, scores, their uh, performance, their attendance, and so on. I don't know. But I'm going to study the sample, and based on that sample, I'm going to draw some conclusions on the entire population, that is my entire statistics class. How do I go about creating a sample? Now, what I would do is, perhaps in a very simple, old-fashioned way, I would have somebody write the names of the students on small pieces of paper, fold them, all right? I wouldn't even do that myself, because perhaps if I do it myself, if I know my students and I try to do it myself, there could be some subjectivity involved. I may end up selecting the better students or my favorite students, I don't know. All right, so it's always advised that you should not, or whoever is performing the study should not be a part of the selection process. So I would have somebody else do the sampling for me. So, and that person is going to write each and every student's name on a piece of paper, on not a piece of paper, on separate pieces of paper, chits of paper, and the person is going to fold all the papers and put them in a box. All right, so here we are going to have 30 folded papers with every student's name written on each one separately, but written only once. All right, every student has their name appear once in these pieces of paper. And then maybe a third person comes in and is asked to draw a piece of paper from the box. All right, so let's say the first name that is drawn is Anne. So Anne becomes a part of my sample. All right, and then we shake the box again. It's just like playing a raffle, really. The box is shaken again, and then the person has asked to pick a second name, and let's say this time Gary is picked. So Gary now becomes a part of my sample. All right, and then maybe third time another name, I don't know, David is picked. So David is the third person in my sample. And then let's say Christine is picked. C is part of the sample, and I said my sample size should be 5, so we need somebody else, another name to be picked, and let's say this time it is Elizabeth. Right, so A, G, D, C, E. Now I have my entire sample. All right, all 5 names have been picked, and my sample is complete. All right, Now it says here, a simple random sample is one in which each possible sample of a given size has an equal chance of being selected. And that's a very important characteristic of simple random sampling, because each person's name here in this case was written just once, appeared in this box just once. So each person out all these 30 students whose names were there in the box had an equal chance of getting picked, 1 out of 30. There were a total of 30 pieces of paper, unique, with each name written once, and every person had 1 over 30, or an equal chance of getting picked. It was just bad luck, or it was just luck, probability, chance that these persons were selected and the others weren't. All right. So that's what we understand by equal chance of being selected. That's very important. Now, in earlier times, before the age of technology, there used to be random number tables, all right, instead of really having somebody pull a name from a hat for statistical studies, large scale statistical studies. Mathematicians had tables from where they would pick random numbers and use it for their sampling. However, nowadays we use technology. Random number generators are available on your laptops, on your computers, whatever you use. Any statistical package offers a random number generator. There are many apps these days you can download which will give you a random number generator. However, for this course we have some exercises in your homework assignments where you will need to use a random number table. All right, so it teaches you how to use a random number table, and that will give you a flavor of how the tables were used in the past. But really, nowadays in real life applications, we don't use tables anymore. We just use technology. Okay, another thing is a simple random sampling can be with replacement or without replacement. The fact that we were pulling a name once and that person's name did not go back into the box. That means once a piece of paper was picked, it was thrown in the trash. All right, it did not go back into the box. That means it's without replacement. So that person does not have a chance of getting selected again. Right, that's what without replacement means. Once you pick an item or you pick a name, once a name has been selected, there's no chance of that name getting picked again or that item getting picked again. That's what without replacement means. And with replacement is when you put back the name into the pool of names or whatever you are selecting into the pool, and then it has a chance of getting picked. Usually when we work with numbers and letters or combinations, or we try to create combinations, maybe license plate numbers or those in those situations we use with replacement. All right, so we can have, for instance, a license plate number which is maybe A1A and then B2C. All right, so here you see we have repeated the letter A, and this is perfectly okay for license plate numbers as long as it's a unique combination. So those are cases where we use the replacement methodology. But in most cases, when we work with people or items, we deal with without replacement sampling techniques, right? We are now going to understand the process of systematic sampling. It says here this process involves randomly selecting a starting point in the population, and then we pick every nth item from the population for the sample. I'm going to illustrate this with a simple example. Let's say I have a class size of 20 students. All right, so my population N is equal to 20, and from my class of 20 students, I want to select a sample size of 6. So out of 20, I want to select 6 students. So the first thing that I do is I number the names of the students in my class and arrange them in a systematic fashion in rows. So I'm going to write here 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10, and then 11, 12, 13, 14, 15, 13, 14, 15, and finally 16, 17, 18, 19, 20. All right. So now I have arranged my students, all right, the names of the students, and numbered them and arranged them in rows of 5. In the next step, I will need to generate 2 random numbers. One will give me a starting point from where I will begin my selection. So I will need 2 random numbers generated. One is going to be the starting point from where I begin my selection, and the other one is going to be the interval, because I'm going to pick a student after every nth number or every nth item. So that's why we need a random number generator to give us 2 numbers, one to decide on the starting point, and then the other one will give us the interval after which we pick the next student. So let's say I run my random number generator, and for the starting point I'm given the number 4, and for the interval I'm given the number 5. All right. And remember that my sample size is 6, so I have to walk through my arrangement to pick 6 students out of 20. So now that my starting point is 4, I go and pick the 4th student, right, from my arrangement. So 4 gets picked. Student number 4 gets picked. And then after 4, the interval given to me is 5, right? So I pick the 5th student that comes after 4, after my starting point. So I walk through this. So 5, that's 1, right? 1, 2, 3, 4, 5. So 9 is the 5th student that comes after the first one. So 9 is going to get picked. 9 is going to get picked. All right. So the next student picked is 9. Now, as I pick my students, as the students get selected, I'm going to cross out these numbers so they don't get picked again, because I'm using the without replacement method of sampling. So 9 gets picked. After 9, again, I'm going to count 5. So 1, 2, 3, 4, 5. 14 is the 5th student. So I'm going to pick 14. And then again, start walking. 15. So that's going to be 1. After 14, that's count again 5. 1, 2, 3, 4, 5. 19 gets picked. And we better cross them out as we are picking them. All right. So now again, we just have 4 students. We need 2 more. So we again start walking. So 1, go back to the beginning. So after 20, go back to 1. So 1, 2, 3, 4, 5. So now this time 5 gets picked. 4 has already been selected and it's crossed out, so don't count 4. It's going to be 1, 2, 3, 4, 5. So 5 gets picked. 5 gets picked. and I'm going to circle that and cross it, or box it and cross it. And now I again begin. I need one more student. So 1, 2, 3, 4, 5. All right, so 11 gets picked. 11 gets picked. So now I have all 6 students that I wanted for my sample size, and I can stop the process. So as you see that we are, there's a pattern. There was a system in our process of selection. We first ordered, numbered, and arranged our population, the items, the students, whatever we are working with, in order, in a proper order. And then we decide on a starting point from where we begin the selection, and then we pick after every interval that was given to us, we pick that particular item or student or whatever we are working with. All right, so that's the process of systematic sampling. Now here they've given us a few steps to uh, tell us how we can go about the process, how to pick the starting point, maybe how to pick the interval, but we don't need to follow this process unless the question in your assignment asks you to follow the process, a certain process. Then of course you have to follow that process. However, this is just to give you an idea of how the process may work, but I think it's easier to understand from the example I just showed you here. We are now going to discuss the next sampling technique, which is called the cluster sampling. The cluster sampling is used when the population is spread over a wide geographical area, and we want to ensure that we have representation from the different areas of the population, right? So for example, let's say that our study involves the entire United States. It includes members from the entire United States. Now, the US is a big country, so we want to include members from the different regions of the United States. If we just use the simple random sampling technique, then we might end up with people only from one area of the country and people miss out including people or items or whatever we may be researching on in our sample. To avoid that, what we may want to do is we divide the population into groups, also called clusters, and that's where the name cluster sampling comes from. So if we are working with a population that spreads over the entire United States, one idea would be to divide the population into, let's say, 6 regions. So I'm going to write here 6 regions, 5 and 6. And let's say the first region is the northeast section of the states. Number 2, let's say it's the southeast. And then let's make the third cluster south, and then Midwest, and then maybe southwest, right? And finally west. So we have our 6 clusters, which represent the 6 regions of the country that we just formed just now. All right, now we have to randomly pick a certain number of clusters. So you have to decide on the number of clusters you want to include in your study. So let's say the number of clusters I want is I want to pick 3 clusters from here. So we have to decide on that. So now let's say I decide on 3 clusters. I want to randomly pick 3 clusters out of the 6. So I use my random number generator you have to have the random number generator give you values between 1 and 6. For that, you may have to do some tuning, some programming, uh, put in some parameters that will generate a number value between 1 and 6, because if you don't do that, the random number generator may give you a value of 20, and we don't have 20 clusters here, so it doesn't make it's not going to be of any use. So that part, that much we have to do. We have to tell the random number generator that we want a value between 1 and 6. All right, so after we do that, let's say the first time we run the generator, it gives us a value of maybe 2, and then a value next, let's say we get a value of 4, and then we get a value of 5, let's say. All right, so these are the three numbers given to us. So that means we will have to pick number 2, which is the southeast in our sample, and then 4, which is the Midwest, and then 5, which is the Southwest. All right, and then once we pick these clusters, once we select these clusters, we will include all members in those clusters in our sample. So the sample will consist of all members from these clusters. So that's how the cluster sampling technique works. Now, the disadvantage of this is we still see that there are clusters that are completely left out. For example, Northeast. Northeast is a densely populated section of the country. So we will have missed out the entire Northeast. So that's the disadvantage of the cluster sampling, but still it does include different regions of the country, right? Southeast, the Midwest, the Southwest. So it does span through the country to pick members of the sample, but it does leave out certain sections of the country as well. So to get around that, we have another sampling technique that we learn about, the stratified sampling, in the next slide. But this is how the cluster sampling works. We are now going to talk about the next sampling technique, which is called the stratified sampling. And you will see that this is very similar to the cluster sampling with a slight variation. If you recall the cluster sampling, in the cluster sampling, we had divided our population into clusters, and then we picked a certain number of clusters in our sample and included all members from those clusters in our sample. The downside of that was that there were some clusters that were being completely left out. They were not represented in our sample. The stratified sampling, on the other hand, is the same process to begin with, but we make sure that all the groups are included in the sample. All right, there are members from each and every group that we create would be included in the sample. So let's consider an example here where we want to do a research on the undergraduate education at a university. Now, the undergraduate education is divided into 4 years, right? So let's say our study is on undergraduate students at a university or at a college. And we want to make sure that we have representation from all the 4 years of undergraduate level education, undergraduate years. So we divide the students enrolled in the undergraduate school into the 4 years, and we will call them stratum. All right, So the first year is the freshman year, right? Freshman year, then we have the sophomore year, then we have the juniors and the seniors, juniors and the seniors. So this represents our strata, and the single one is a stratum. All right, the singular form of strata is stratum, and that's why they say that sampling is done from each stratum. uh, so what it says here is stratified sampling consists of dividing the population, which we just did, into subpopulations. So these are the subgroups or strata, and then sampling is done from each stratum. And so step one is divide the population into subpopulation, and then step two is we will be drawing a we will obtain a simple random sample of size proportional to the size of the stratum. So that means we will randomly uh, decide that we are going to get maybe 20%. We are going to include 20% of freshmen in our sample, maybe 15% of sophomores, 25% of juniors, seniors, maybe another 20%, right? And create our sample. All right, so that means if there are 500 freshman students enrolled, we get 20% of the 500 and randomly pull those students into the sample. Then if there are 200 students in sophomore, we pull 15% from the sophomore group, from the sophomore stratum, and pull them into the sample. So that way we get representation from all the different stratum in our sample, right? On a percentage basis, none of the groups are left out from the sample. They have equal representation. All right, so we use the proportion method or percentage method to pull a certain amount of students, certain number of students into our sample. That's how the stratified sampling works. The last type of sampling study on our plate is the convenience sampling. Now, this is not a recommended method of sampling that one should use for a statistical study of any importance. It's a non-probabilistic method. It's not based on simple random sampling. It's just based on convenience, right? So we just poll, or we just create the sample or get the sample from the part of the population that is easily obtainable. For example, let's say I've been asked to do a study which is not of much value, hopefully, and what I do is just before going to work, I stop by at the nearest grocery store and I stand at the door, pass out my survey to the first 20 shoppers that are coming in. After they fill out the survey, I collect it and leave at my convenience. All right, so I go there at a convenient time that suits me. I spend very little time in collecting uh, the surveys, and my sample is just the first 20 shoppers in the store. All right, so that is not considered to be a scientific sampling method or a scientific way of getting our survey. All right, so that's what convenient sampling is, and definitely it's not recommended to be used for any good statistical study. Now, before ending this section, I want to talk a little bit about the sampling error, because that's a terminology that we will be using frequently over the course of our study here. All right, so a sampling error occurs due to the differences in measurements between sample data and the actual population data that occur as a result of using a sample instead of the entire population. So we said that, yeah, we want to study the entire population. That is our subject of interest, is the entire population, but since it's not possible to work with an entire population due to its size, huge size in millions perhaps, we get a small subset from the population, maybe a few hundred or a few thousand, and we work on the sample. So we perform our descriptive study and do our measurements on the sample instead of the entire population. And when we do that, the measurements based on of 2,000 people, for example, or 2,000 items, for example, is of course going to be different from what we would have found, what we would have got if we had included the entire population of millions, right? There's going to be a difference in the measurements because the population is in millions perhaps, and the sample is only a few thousand members from the population, and therefore there's going to be a gap between the measurements if we had taken the entire population versus if when we take just a sample. And that gap is referred to as the sampling error. It's the difference in the measurements, the difference that would have been in the measurements if we had done the measurements on the entire populations versus that of the smaller sample. All right, and that difference is the sampling error. Sampling error does not mean that it's an error as we know it, as making a mistake or something like that. No, error refers to the gap between the values in our measurements that happens between a population and a sample. So here, as a simple example, we have population data. We have 6 values for population: 8, 10, 13, 17, 20, and 25. If we found the average of these values, which represent the entire population, we got a mean of 15.5. Now, if we took samples of size 3, if we drew samples of size 3 from this population data, the first sample is 8, 10, and 13, right? So if we take the average of these 3 values, we get a mean of 10.33, an average value of 10.33. If we had chosen 3 other numbers from the population, 13, 17, and 25, and found the average of those, we got a mean value of 18.33. So these differences that occur due to using a sample instead of working with the entire population is what's called a sampling error. All right, so it's the difference in means between the samples and the actual population. That's what is called the sampling error in statistics.